been using AI in Aegis for quite a while now, and by AI I in particular mean large language models, LLMs, like ChatGPT, Claude, Bard, or the others that are making headlines at the moment that you have to be living under a rock not to know about. But we've been using them in the same way that I think many automation agencies apply them, in tightly defined processes that are mostly automated, but then leverage something that the large language model is really good at to do a single part of it. So, for example, LLMs are great at summarizing, they're great at inferring things, they're great at transforming text from one language to another, say, they're great at expanding upon something. So you may summarize an email, or you may answer some questions that a customer has about your product with an AI. This is a perfectly good application of it. The flow of how the problem is solved is tightly defined, but there's a specific place where you can use an LLM and therefore make the whole thing much more cheap to implement as an organization. Then at the other end of the spectrum, you have the stuff making the headlines, where we basically think we can take these large language models and structure them into being almost autonomous agents or AGI. Where we're able to say solve unstructured problems, and that's not pie in the sky. That is something that's happening. I don't think we're at a stable, amazing point where that's something that anyone can use effectively. But I think we're going to get there much quicker than most experts are willing to comment and say. Most progress in AI has been quicker than the experts thought it would be lately, because there are so many clever people working on these problems. So these two extremes, having this almost general AI brain doing unstructured problem solving, and this extremely tightly structured problem where everything is known apart from a little bit where we'd like to use AI input to produce some human sounding output, they're really quite far away from, I think, where most actual real-world business problems are, and I don't see much discussion about it. Most problems are quite well structured, but a human brain is better at navigating that structure, carrying context along for the ride, than any AI or AGI can currently do. So I wanted to talk about this third way, this in-the-middle way of dealing with structured problems with AI, and how in a very real example, a business problem we actually have, we're going to be trying to solve that. I wanted to share that with you. Okay, so for an example of the AGIs, the attempts at general intelligence by structuring these large language models to via maybe a chain of thought, thinking step by step, or a tree of thought. Well, there's a bit of programming behind this basically that's layered on top to get the LLM to think in a structured way to solve problems. And so there's an obvious issue that it has to have a structured way programmed that's going to work for all kinds of problems. And, well, that's hard. So these things don't work brilliantly. Here's an example. So on the screen, we've got an attempt that I made just to test and see how it would work, where I would try to find email addresses, mobile phone numbers of some personal trainers around the UK. I wanted them to be in different cities, so I wouldn't be targeting competitors of each other in the same city and trying to sell our accounting services. We have a couple of fitness trainers on the books, and it would be great to have some more because we know how to serve them well. So there's a good impetus behind why we would want to do this. I asked godmode.space, which is an implementation of AGI, or an attempted implementation that does this kind of structured thought to solve the problem for me. And you can see the kinds of problems that it came up with. First off, it started with a Google search, which is probably not the best place to start, but it was what it thought. I will search Google for whole lists of personal trainers. Didn't really come up with much use. Certainly I as a human wouldn't have taken that first step. So we have the 20 best personal trainers in London, a number of personal trainers in the UK, how to find personal training clients with Facebook ads. I mean, these are obviously not going to be relevant results where I'm going to find contact details of personal trainers to try and sell our services to. But my human brain being aware of that is not the same as this large language model coaxed into thinking as much like a human as possible. And so although it has some useful things down here, it knows that it will need to visit each website to check if the Chinese have started advertising the services in the last year. I wanted the new ones. It basically doesn't have the right structure from the problem, so it's not going to succeed in solving it. So we abandoned that. The next one I tried, I had a particular director and company. I think it's probably a good example of one that was always going to fail. I didn't have contact details. I only had a director name and a company name, and I wanted to be able to find that particular person and company. And because this is a specific problem we have within Aegis, where we want to contact these directors and help them with their, say, first accounts, this is the kind of problem I'm really trying to solve right now. But I can look at this and already know from having tried this problem that it's unlikely I'm going to find this person. First, this name is not incredibly unique, so there's going to be a lot of Ruth Welshes out there. This is not a limited company name that is going to be marketed. It's been left as a number. So it's unlikely I'm going to Google and find that company. Probably as a human I'd ditch this one, but I wanted to just pick one and see how it would structure going about solving the problem. So here's what it's decided it will do. It will search online directories for contact information. What online directories? Well, I don't know, but it seems to know. So where is it going to search for them? It's searching for, I don't know, but it says it's found a text, Loughborough University's website. Okay, apparently there's someone at Loughborough University called Ruth Welsh. It's highly unlikely that Ruth Welsh is this one. And yet it thinks it's done. And it was ready to provide me with the phone number and email address. It's not right, but it doesn't know it's wrong, because it's not a human brain with all the context that we've collected through our lives. It is it's a large language model. It has trained itself up on the internet of text, and it is able to pluck an awful lot of knowledge out that is generally known, but it has no specific domain knowledge about how to do this particular problem. So it is making guesses that aren't right, and you would need to guide it. If you were trying to coax complex results out of ChatGPT, you would expect backwards and forwards some conversation to try and get the right kind of thing out. There's no way of doing this with this kind of solution. You're going to tell it the goal, and it's going to go and try and solve it itself. After all, that's the point. So godmode.space didn't work for me. There are others. There's SuperAGI. This one was terrible for a different reason. By the way, I think these are great tools. They're just not at a stable state where you can apply them to all problems. I'm seriously closely watching them. They will solve many of their issues and become powerful. For now, they're not quite there. This one decided that it would take my CSV file full of contacts and spit it out entirely into the API for the large language model I was using. It was GPT-4. Again, that's OpenAI. It's not the one that ChatGPT uses unless you're Plus and you clicked it. Most people are on 3.5 Turbo, but it's expensive to run compared to 3.5 Turbo, compared to what ChatGPT runs at. So I don't want to make giant calls with 30,000 tokens, because you can split the whole file out in several sequences and then ask, what should I do with it? So this one I tried to cancel immediately, thinking that actually it cost pence, but I didn't want to do it that way. It was already obviously inefficient. It doesn't know how to structure the solution of the problem. It is going to make a good stab at trying to do so. Another one that I've used for different things, but also has an agent sort of approach. They have a dashboard where you can run an agent. They have a fantastic way of dealing with watching what the agent's doing and its progress, how it's structured them, and you can infer and sort of teach it as it goes. You can talk to the agent as it's working, and that's really powerful. I really want to watch CheatLayer. I'm really impressed with what they're doing, but CheatLayer seems to me far more focused on working in the browser. I would need a clean Chrome profile working in the corner, constantly doing what you would do as an end user, which actually is often the right thing to do. So I think it's a decent approach. It's not necessarily the approach I want for this. And just like some of the others, it didn't always go about things in the right way. One of the cons for this particular platform is that you're always attempting an automation like you're mining for jewels. There's lots of them and you will find them, but you've got to try again to find the right way to prompt it to achieve the outcome you want. Once it's got it, it's got some ways of holding those skills within the CheatLayer platform, so it will only get better with time. Again, really want to watch. But for now, I found I was spending too much time trying to find an automation that might work. Can I prompt it that way? Does it do the thing I want? No, okay. And there wasn't quite enough visibility into why something failed. I don't want to be diving into the browser console all the time, and often when I didn't understand what I was looking at anyway, because there wasn't enough transparency in the error messages. So, and again, brilliant piece of coding, brilliant platform, really looking forward to seeing it grow, really watching it. But all of these AGI tools, or these agent tools, they take a single goal and they can take guidance often along the way, especially this one in CheatLayer, and they can improve, but often you already know the structure of how you would go about solving a problem. If you've got a challenge in your business that you would normally give to a person, you probably already have a loose workflow around it that you'd expect them to follow to solve it. So the last version of one of these AGIs I want to show is probably the most promising. Generally the most promising approach. This is called ChatDev. This one has each LLM playing a role, and in particular this one is for software development, so you can see the problem initially. I'd have to repurpose it to be applied to something else, possible, but not what I want to do right now. It's like you have your CEO and your documenting team, your testing team, your coding team, and your designing team, and each of those is an LLM. Now this naturally solves one of the big problems with AGI in general. The context, that is the short-term memory of a large language model, is quite small. So you can't really throw a huge amount of all of the context and information about what's going on consistently without it starting to get stuck in loops or making mistakes, or costing a lot by putting an awful lot of information into an API that you pay per use. This kind of solves that, because when you think about these problems as being solved by a team, each role only needs a certain part of the context to work from. Your testers need to see the code and to know what the tests are, but they don't necessarily need to know what the CEO is thinking about the long-term strategy. The documenting team might need to inspect the code, but they don't care necessarily about how the design team has come up with the user interface, for example. Maybe, for example, user interface would be documented too, but you understand each single role has a very limited context. Much like if you had an employee, you would tell them all about the company and the high-level context, and then tell them some specifics about what they're expected to do. You don't need what everyone is doing in that context. You don't give them the whole book, the whole playbook for how the whole organization works. Too much information, most of it irrelevant. So this looks like it's really promising, and it has produced some brilliant outcomes. There's some various screenshots of successful pieces of software that have been produced from this approach. It also works on local large language models too, which I think is really interesting, because then we're not necessarily even using external APIs like the very powerful OpenAI GPT-4. You could be using, say, Llama 2, which is a free and almost open source, almost entirely open source for nearly everyone who isn't super large. And you could run locally, perhaps a little slower. I don't know, haven't tried it, looking forward to it, but I haven't done it yet. So it's very, very promising to be able to solve general problems locally with these incredible tools at some point. And it can be customized. Further down here, I think I saw you have the roles listed out. You can change what the exact role of a CEO is, what the exact role of a chief product officer is, and you can change it specific to your scenario. And maybe we could morph it into being able to solve other problems, but that's more work than I'm willing to get into, especially as I think the problem that it would still face is it would resolve a problem several times. If I want it to create Snake, the fantastic little game that used to be on the Nokia phones, if we make it make that, and then we come along with a new installation tomorrow and we ask it to make it, it will make it from scratch. they'll resolve all the problems. It won't learn the skills as it goes. At least that's my understanding. Certainly that's true of when you call the API or when you start a fresh ChatGPT conversation, fresh brain every time. So you don't get the context unless you put the context in. There are ways of doing that, and that's what a lot of these AGI things solve: how to put context in a way that can be manipulated to solve complex problems. But this is that far end of the really, really general purpose. Can you solve a generic, an unstructured problem? Most of the time in the business, I've been applying LLMs to tight automations. So, for example, answering an email in a realistic way. Most of the process of answering an email is extremely programmatic. It's only the content of the email that I want to be human-like, that I would use an LLM for. I wouldn't ask an AGI to answer my emails. I wouldn't ask an agent to answer my emails because it's a sledgehammer to crack a walnut. I would ask an LLM to produce the text for the email, and the rest is programmatic. Doesn't need any of that constant problem solving. It seems wasteful to me. So in the middle is where I think most of these real world problem lies. And so here's an example of one of those problems we're having to face, and how are we going to face it? So I have in the business a list of leads that don't necessarily have contact information. In fact, they almost never do. All I have is a name of the company, and these are ours and my wife's, so this is not this is not a client list, but or a real lead list, but it illustrates what we have. We basically have a name of the company and the address of the company. We have the shareholder and directors, incorporation dates, and a couple of other technical things like that. We don't have any contact details. So the way we do it currently to deal with that is I have a form pre-filled per line based on what's in there. And then I get to focusing just on this company, and I basically have to do a whole load of web searching, enriching this lead with contact details I may or may not be able to find. So I have the name, I have the registration number, and various other bits all filled out, and then there's a couple of things blank. I can find the company's house link, it's relatively easy. I can search for their website. If their website is there, and not all companies have a website, loads don't. The ones that do may have a telephone, may have an email. Then I may find an email for the director, quite possibly by going through their LinkedIn first. If I find the company on LinkedIn, I may find the director. If I find the director, I may find director contact details. Then I can contact the person I most want to contact about the business. There may be some Facebook pages, other socials. I would like to note other stuff that I think is important. And then when I go to do a relatively generic email, most of the content's generic because it's targeted campaign to specific clients we really want. But I still want to be clear. I have gone through this process. I have looked at them. I have looked at the website for this business. I've looked at the profiles, and I thought, yes, this is the right kind of business. I do want to engage with them and hopefully, gain their trust and they become a client. So in order to illustrate that I have done that and I haven't just spammed an email out to everybody, I need to show some personalization, and so I do that. Very human job. Sometimes I'll go through this, and rather than doing any of that, I'll abandon it quite quickly. Maybe in this campaign in particular, where I'm trying to find people who have yet to file their accounts, maybe they were already filed in between me getting the lead list and looking at the website. Maybe I just can't reach them. So I'll go through all of this process. It's not a clever process. I don't need to be a really smart person. I just need a human brain that sees patterns. Maybe I'll see the profile photo of one of the directors, and I'll see that somewhere else in a web search and go, oh, that's the same person. And then I can find, maybe through their Twitter profile, maybe I'll find that, oh, that is the same person. Look, I can see their face is the same. Or maybe I'll find a profile for them as a director. It's not linked, but it's in the same place with the same industry, and I'm almost certain this is going to be the same person. They just haven't linked themselves to their company because maybe they're a contractor, so they're linked with the company they work at rather than the contracting company they run. A human can work these things out. So could a well-structured problem-solving LLM or AI or agent, or more likely something in between. And so I wanted a way to solve structure problems with large language models. I tried this a little while back when I was trying to get to grips with CheatLayer, I wanted to solve one of these problems that is well structured. And what came to me is that these large language models can speak a variety of languages, or rather type out and understand a variety of languages, including programming languages. And I wondered, is there a programming language that represents steps in a workflow rather than a list? Because quite often a list isn't enough. There are too many branches, if this then that. I don't want to write out a huge actual piece of programming, because if I did, I might as well be actually programming. What I want to do is I want to give it a sequence that it can reliably follow that is well structured. It took a bit of searching. What I found was something called plant UML. So plant UML is, think of it as pre-programming language. So before you actually program something, you'd want to diagram it out in something like this. The specific one we're thinking of is activity diagrams, and they look a little bit like a flowchart. Basically, they go from a start to a stop. They may branch, they may have some if-thens, they may do some things in parallel, but the idea is that it's a good way of structuring going from one point to another point. A self-contained problem that you might give to someone probably can be at least vaguely well represented in that form. So I wanted to be able to do that using LLMs, and I thought, well, first I should test, can it read the language? So I wanted to find some examples. These all seem just a little bit too simple. This is about as complicated as I could find it. Really not very complicated, but I just thought, okay, there's an example and there's the code. Saves me writing the code. So I copied that and I brought it into Claude. Claude was my choice because I know it has a large context, but it is functionally fairly equivalent to ChatGPT. So I thought I'd give this a go. And I told it, follow this activity diagram step by step, asking me questions to determine how to proceed at each step. The diagram is as follows, and then I pasted it in. And this is what it said. So let's bring this off to one side, and let's bring this so we can go by. You can see the diagram, we can see what it did. Okay, so it started. First, it's a start step. Choose diagram type to suit message and audience. Great, it's got that right. I've chosen one. I just made something up. Got it. Choose example diagram and copy code. That's the next step. Perfect. Done. Okay. Then it asked me the question. This is the first actual bit of logic here. Is a diagram finished? I said no. It successfully figured out that it should go to update diagram code and so on, render and view diagram. Then I said it was done. I said no, it's still not finished. When it asked again, and we went through another loop. This time I said yes, it's finished, and it went through correctly to publish a diagram. And I said it was done. It's a fairly simple example, but the idea isn't that it's successfully doing something complex. The idea is that it's successfully following a flow that is determined in a language sort of similar to programming that a human could follow. So let's see if we can... Yeah, the next step was, if it can read the language, can it produce the language? So I asked it to do that for me. I told it that I wanted a plant UML diagram of exactly the process we were talking about earlier. I want to find an email address for a given director of a given UK limited company. That was all I was going to give it. And here it suggested one. And there's the code straight away within seconds. So copied that, pasted it into the online version here, which is plantuml.com. They have an online one which will turn it into a picture for you. It'll also make sure it's in the right language and it's actually working. There are no syntax errors. There were syntax errors, as there often are when you do the first round. I described it, didn't fix it right first time, described it more precisely, and then it fixed it. When I copied it in, here we go. And this is basically what Claude, a large language model, came up with as a structured way of solving the problem of finding an email address for a given director of a given UK limited company. It's not bad for a first go. Going to take the company name. It's going to look that up using the Company's House API. As an individual, I'd just use the website, but I understand why it thought the API was better. Did you find the company number? No, it's not there. Nothing more you can do. Makes sense. It is there. Great. Retrieve a list of directors using the Company's House API, or I'd navigate to the right part of the website, but same idea. Then select the director and search the director name on LinkedIn. Do they have a profile? Yes. Retrieve the email address. It doesn't say about what to do if there is or there isn't an email, but this is certainly part of the structure I actually do. If it isn't able to find it, try alternate search engines like Google, Bing, etc. Either find it or you don't. Absolutely fine. Look, and it decided that there was a loop here to try a different director. So if you couldn't find the email address, try a different director. I didn't tell it to do that. I didn't even tell it that there might be multiple directors. As it happens, we've been filtering for really, really small entrepreneurial individual ventures. So we've been selecting single director companies, but it naturally thought about several directors, and it structured the problem. A blank brain version of Claude, where it's forgotten all of that, but I present it with this code, can also navigate this, which means that one of these AGIs, if it could be given, rather than say a list and some goals, if instead it could be given a flow, then it would have a much better way of solving already well-structured problems, because it can deal with natural language prompting, like look up company number using company's house API. They can manage that. There are already tools using LLMs to do that. Look up Open Interpreter. That's a way of running these things on your local computer right now. It just deals with them. So a lot of these things are already possible. So yeah, that's what I think we need to see. We need to see ways of making the structure, also conveying it to us as individuals. I want to be able to see this and know what it's doing. Otherwise, I don't know how it's working. I often I have in the past looked at CheatLayer's agent interface and not really understood what it's doing. I'm seeing a progress bar, but I don't know whether it's just wasting API credits doing something that isn't going to help. So I want to be able to implement this. So this is us now going to go and do this somehow using UML to get a structured flow solved by a large language model and followed by it and acted upon, maybe with SuperAGI or something like that, where it can use tools to achieve some of the bits along the way. So I use another AI to figure out how to do that, because I exclusively search on Bing now because I can use Bing Chat. I ask the question, is there a linter for Plunk UML? If I'm going to code in that language, I need there to be a linter. For anyone who does programming, you know what that is. If you don't, then that will tell you as you're typing if you're making an error in the syntax. So that's extremely helpful. Usually it'll review the syntax and tell you something helpful, like how to fix it. So you need those things in order to be able to practically code in a language, especially if you're not familiar with it. I'm not that familiar with Plant UML. This is new to me, so I'll need it. And yes, there are some. It tells me there is one for Visual Studio Code, and so we will link through to that and discovered it. Yeah, absolutely brilliant. This it means I can now use Visual Studio Code, a very common programming platform, programming sort of code editor, to create it and also see it as I'm doing it. If you're following along and you want to do similar things, you don't actually need Java. OpenJDK is good enough. OpenJDK is a little bit less proprietary. It seems to work. GraphViz you will need to download. And it works really well. So here's that activity that we came up with. It already told me through linting that I should add a title here. It's fairly minor, but it's useful. And it shows me a preview of it on the right-hand side. And so I can now edit and change, start documenting a workflow I want solving, something simple, like how I go about this currently very manual process of enriching leads with contact information, and then have an LLM be able to take care of that for me. When that is an automatable process, that's a lot of my time saved. Right now, in the middle of a campaign, several hours each morning, I'm going through a long list of contact information, of names and companies, and only about a third of them do I find any contact information. Many of those are LinkedIn. I don't currently have Sales Navigator yet. When I do, I'll get in contact with some of them that way. So even smaller amount are coming up with mobile numbers or emails I can then contact. So to be able to automate this process will be a massive, massive win. Okay, I think that's pretty much it. I think that's all I wanted to go through. Structured problems are this sort of untapped area where no one's really talking about. I think it's most important for a business right now to be able to solve problems that are well structured. When I did search just simply for solving LLMs, solving structured problems, the new piece of research came out, might be useful in the future. It's graph of thoughts. I think earlier I mentioned chain of thoughts and tree of thoughts. These are specific processes whereby a structure is placed around the kinds of prompts given to large language models to make them return the kind of information that you want and solve problems arbitrarily, arbitrary problems. Graph of thoughts is an extra level, it seems, of flexibility about how it structures its thinking process and how it goes about solving those problems. That could be interesting to see. It could make the attempts at AGIs that much better. It certainly suggests with its results that scoring quality of sorting is 62% over tree of thoughts. So it has promise. Maybe we'll see more of it in the future. But for now, I'm certainly going to be working on dealing with structured problems in a structured language and trying to get a large language model to follow that and perform those natural language phrased steps as it goes, because I think that's going to be a seriously efficient way of dealing with the kinds of problems that don't require much cleverness, but really excel with the kind of context that human brain can bring to doing it. But they're simply just, these are automatable things now, and yeah, I want these done better, faster, cheaper, and I don't have an employee. So this is my opportunity. Hope you found that interesting. It's been the first video I've done like this, so I hope I didn't ramble too crazy for too crazy long. I think I did. Never mind.